Everyone, this is our MOOPy project for BREE518 course. Our topic is Design of Structural Low Impact Development Practices for Urban Stormwater Management.
Low impact development is the stormwater management technology to manage the volume of runoff and stormwater. The technology is initiated in Maryland in the early 1990s. Goal of using LID is to detain runoff, encourage infiltration, and reduce runoff volume. There are two design control measures in LID design. The suitability of LID control are based on the proposed length. The first control measure is lot level control. And here are the list of technology used for lot level control and evaluation of design. Second control measure is conveyance control, and same as previously, here is the list of technology used and evaluation for the conveyance control.
So here is the case study we're going to talk about in our. This is the government project of the City of Ottawa about low impact development demonstration project for the formal Canadian Force Base. The goal of City of Ottawa is for the formal CFB Rockcliffe development to be a model community for LID. Meanwhile, to implement LID's product development, monitor gain experience, answer key questions, and build capacity in the phase and control setting with the willing partner. There are overall 4 phases anticipated to be completed for formal CFB Rockcliffe site specifically. Our project focused on 1A. In this project, Phase 1A is selected as Stormwater Management Demonstration Project by using LID, which encompasses area west of Coast Road and will service trailer-related road-wise residential land use, parkland, and municipal road. The criteria for suitability of LID controls at the formal CFB Rockcliffe site has been evaluated. It includes predominant soil types, primary land uses, available area, implementation cost, types of expected infrastructure to accompany site development, and general City of Ottawa policy considerations. Here is the criteria we've been talking about in the previous video before. Here is a list of design guidelines in this case study. There are various approvals need to be involved in this project as well. Let's talk about the LID implementation of this case study. This is one example of soakaways. Downspout disconnections are proposed to direct roof runoff to front yard. The subsurface soakaways then infiltrate. Soakaway locations were selected based on type of proposed building or structure. Access points from roadways, for example, driveways or lineways, as well as forecasted utility conflicts. This is enhanced swell. Enhanced swell, as detailed previously, to encourage infiltration, reducing stormwater runoff, and to minimize clean sources of runoff from external areas to the south from entering the conventional stormwater management system, like pipes and ponds. An enhanced swell is proposed for integration within the southwest channel of Block 2. Bioswales also applied in this LID demonstration project. Bioswales to accept road runoff and drainage per the proposed road cross-section 1B. It's proposed that bioswales be incorporated into the municipal road. All green spaces, like grass or vegetated, are proposed to include soil amendments in conformance with the implementation guide. Look what I'm playing with! Those are data loggers. Why are we use them? We use them to collect soil moisture content data and feed them into models. A post-development predictive water budget model was developed based on the EPA Stormwater Management Model hydraulic model. In the development of a hydraulic model for post-development conditions, the areas where post-land use were overlaying the drainage areas, and the boundaries assigned as part of the existing conditions in the model. Parameters such as imperviousness, values, and depression storage were adjusted to reflect physical change under post-development conditions. The techniques of maintenance requirements based on type of LID controls such as suckaway systems do maintenance predictably and annually. However, soil amendments don't need to do operation and maintenance.
Thank you for watching our video and teamwork made the best.